Hi everyone, welcome to my channel. I'm José Cruz, I'm an enterprise architect and I like to talk a lot of different subjects due to my experience as a developer, architect, software engineering. I was a trainer for some time. I did a lot of different things on my past and I really like to share it because I have all this knowledge, and usually when I go to a company, I observe all the dev teams, and I think coaching and sharing information that we have, it's always rewarding, not only because it's something that you know and you put outside, because sometimes you really know a lot of stuff, and at the same time you are helping people. And when you are helping people, somehow you are helping yourselves, because in a way your mind starts to organize itself when you explain things to others. So I think it's a win-win for everyone if you follow my channel. Today I want to talk about PostgreSQL, which is a database that it's really popular, and it came somehow as a surprise for me during the last 5-10 years when this database started to see a really option in big companies. And I've worked in big banks on the top 10 of the world, and Postgres was one of the databases that they were using in production. Of course, there were still some SQL servers, oracles and others, mainly because of the past. Banks, they have a lot of they are linked a lot with the past, and they have support from companies like IBM, Oracle, Microsoft, and you always want to make sure that your critical data, if there is a problem, can be supported by a big company with a lot of money, with a lot of professional people that can help you as fast as they can. But for other projects, I have seen most of the cuts in costs to be by removing some licensed databases and moving to Postgres. And we'll see how. It's not because of the price, it's because it's a really good database, very stable, very hybrid. It contains a lot of different features, and at some point in time start to challenge, I think, the domination from MySQL, because people start to use MySQL rather than paid databases. But we are seeing a trend to move to Postgres. I still think that MySQL is a great database, quite standard, used in a lot of different systems, but Postgres starts to dominate somehow, and I will try to explain it. Wow, so this video will be about explain to you several features about this database, like core features and extensions, which is a great thing that is on this database, and if you use it, probably you will get addicted to it. Of course, I will show you that it's a regular relational database with excellent features, so it complies with the ACID. It uses a MVCC like other database, which is a kind of a version mechanism to make the transactions faster and avoid a lot of deadlocking. I will talk about some advanced features like functions that you can use, CTEs, ranks, partitions, and things like that. Some modern data types like JSONB and things like that. So you don't have only tables, but you can also have JSON in your tables, and you can query it. You can, and I can spoiler alert, you can see even arrays. And I will talk then a little bit about the extensions, and then how is Postgres used in the world compared to other databases. I will show you examples in code, so if you are following this video, you will see some examples. I will not explain to detail. For that, I will create featured videos specific to each one of these features, because I think you will have some advantages to learn them. I use them in some of my projects, and that's why I'm promoting this database. I will not say that this database is better than the others. The only thing that I can say to you, it's a very solid alternative, and it's somehow free. I don't like to say free, because someone has to support it. You need time to understand how it works, and the DevOps people and the DBA administration, they spend a lot of money to learn from it. So at the end of the day, of course, nothing is free. There are no free lunches, but you don't have to pay millions or hundreds of thousands or dozens of thousands of euros or dollars every year for license mechanisms for the other databases. So let's see the details. By the way, I always put timestamps if you want to target a specific part of the video. I always try to split my video in what is important, and in this case, I will split it in which one of the features. So be free to jump directly to one of these issues. You don't have to wait for me talking until I'll reach what you want. Okay. So first, the object relational thinking. What's the big deal? What's the big deal about this database? First, it's a relational database. Okay, so what? All the others are also too, like SQL Server, Oracle, MySQL. There are a lot of them, and they are really optimized, very stable, popular, and so on and so on. But this one, we can say it's an object relational database management system, because you have additional features that the other database sometimes they contain in a way. But remember, this one, it's free. Okay, but there are particular things that they are quite nice on this database, and that's why I'm exploring. Again, I'm not saying this is the best database. I just want to prove you that it's a very solid alternative. So first, tables, columns, rows, and good old SQL, all of it exists in Postgres, and sometimes there are small things that make it better than other databases, but you also have access to object-oriented tricks on this database. You can make a table, inherit from other tables. You can even create your custom data types, and I will show you in a moment these examples. There are other things. Again, if you look into the description of this video, it's a spoiler. You can see what I will be talking about, and it's more than what I put it here on this slide. So there is a difference between what you get and what you can add out of the box features. This is just the core engine, and that's the regular things that you expect from a relational database. But this database was designed to be so you can extend it. So you can create extensions to it. Of course, probably we lose a little bit of the performance depending on the extension and the way it is developed. But there are several extensions that are being used, and they are very popular, and no one complains about the performance, because what you expect from the extension, it's best than what you lose about the performance. So you won't need to use an external system or another database. You can integrate within this database, and the data, it's already there. So it's a really win-win, these extensions, and there are a lot of them, between the win-win between, of course, the price you pay, and not money, but maybe a performance, and the usefulness that you need for your use case. So first, it's ACID compliance. This is what you expect for any database. For those who don't know or don't remember, or they just want a quick review about ACID. ACID are the initials of atomicity. It means that everything happens or nothing happens. Remember the cliche use case, if you are transferring money and imagine that it's not the way it works, but let's say it is, and you have to remove some value from a database and add to another database. You want all of these two transactions happen as if they were one. So everything happens or nothing happens. Otherwise, you'll run the risk that someone took money from your account and it was not dropped in anywhere, so it entered to the void, and then you will have a kind of a traceability problem and you lose money, so it's not a good thing. That's why databases support atomicity locally and sometimes distributed. For those, they require transaction manager and probably two-phase commit or similar protocols. And then you have the consistency. It keeps your data neat and tidy, always following the rules you've set up, meaning that if it's an integer, it's an integer. If for this row to exist in this table, it needs that the specific ID exists in another table. Okay, that's consistency. It should work. It should be enforced by database, which is. And isolation, there are several isolation levels, usually 4, but you will see that in PostgreSQL there are only 3, because it will be somehow safer, but it can be challenged, what I'm saying. But isolation means how transactions lead with each other, because you have thousands of requests to a database, and imagine to the same rows. And how can you isolate data when a specific transaction, for instance, is updating a value, but at the same time another transaction needs to read? And there are several isolation levels that you should define. And it's something that sometimes people forget when they are using a database in the project, but it's quite important. It depends on the data, depends on the criticality, depends on the trade-off or the ratio between reads and updates on the database. There are a lot of things, and you should read about it. I didn't start yet my videos about database, but when I start, I will explain into detail what are isolation levels and why you should care about them. And then, of course, there is durability, meaning that if the transaction commits, even if there is a crash on the server, you still see the data. And this is quite profound. I will not explain the details how it works behind the scenes, and I really know quite well how it works because I was a trainer of the database for a while. I'm not a DBA administrator, by the way, but I love data. And let's say that when you work with the database, everything happens in memory, but there is a kind of a log where call it transaction log, sometimes it has other names on the other database, where it is written everything that happens. But even before the data goes to the real database, to the storage. And people say, okay, but am I not reading from the storage? No, you're not. You're always reading from the memory. And then the data is taken from this log and really written once in a while, let's say every 30 seconds or something, to the real storage. So if the server crash and of course this log still exists and you should care for it with backups and things like that, it means that when the application starts, we'll go to the log and check if transactions that, for instance, were committed but not stored in the real database, and then they will go further. It's one of the strategies used regarding the durability. So let's move on. First, one of the features that exist on Postgres, they exist with probably other names or maybe the same name in other database, but it works quite well on the Postgres, which is called multi-version concurrency control. And what it means is that imagine that you have two transactions going to the same row. And what the database does is just to create a copy of this row to the transaction that wants to update. So the update will happen on a copy of it and not on the original one. So the original one keep existing with the old value for a while it's being read until the other one is real committed. One big advantage this is because imagine that you update, and what happens is that imagine that you decide to roll back later about this, which means that potential other transactions could read wrong values. By the way, this is called dirty read, and you can avoid it, one of the isolation levels. But this database and other database, if you configure, support avoid all these kind of problems, dirty reads and similar issues, using the multi-version concurrency control. That's what it's behind. It's not, sometimes people that think that is multi-version concurrency control. It's a kind of isolation level. It's not an alternative to, let's say, the isolation level serializable, but it's just the way the server handles concurrent transactions on the same data. Okay, so it doesn't depend on the isolation level, but helps the isolation levels. Okay, let's see kind of just a visual. Sometimes it helps. I'm a visual person. I like to see diagrams. So you have a row, let's say you have with this value, just for simplicity, I put just one column with the stock equals 1. So there is a transaction that wants to read. So it seeks this version 1, which is original 1, and it will read stock 1, but then the transaction B at the same time wants to write. So the Postgres will create a copy, just clone it, and let's say this transaction that will create this will have this version 2 of the row and move the stock to 0. And when it is committed, now every other transaction will see the 0. But if there was a rollback, the original database data will remain the same, which is a great thing. Of course, there is an impact in memory if you have millions or requests constantly, but it makes your data reliable, which is a good thing. So about the transaction isolation level, since I touch the subject, I will not go into deep, but I wanted to listen to them so you understand what they are and why they exist. Of course, there is a trade-off every time you choose an isolation level. Usually they are, the database came with the default one, but you can change just using a SQL statement to change them. There are 4 levels. One, it's the read and committed. The read and committed doesn't exist per se on Postgres because it works as read committed, and read committed is such a level that it doesn't log almost nothing. You can write and at the same time read. So and imagine in this scenario, if there was no version 2, what will happen? This will move to 0, then a lot of other transactions will read 0, and then there was a rollback and it returned to 1, but a lot of transactions already read wrongly the value. That's it's called dirty read, which is resolved if you move to the default one, which is the read committed. Then you have repeatable reads. I will not go into details, but let's say that you don't have problems with specific values, but you can have problems if you remove or add rows. And it's not as a kind of a dirty read of data, but a kind of a dirty read of rows in a table. So you have a transaction and it inserts, and then imagine another transaction does a sum, or you just remove and happens the same way. And then you have a wrong sum if there is a rollback, meaning that the row was removed, but other transaction already read the supposed new row. Okay, that's one of the things. Unserializable, what it means is that it tries to mimic a kind of a serialization aspect. Like if you have 10 transactions, you expect transaction 1, then the execution of 2 or 3. Of course, that cannot happen in a database. It will be a big problem, because if you have multiple transactions and they go to different tables, of course you want to allow them to go in parallel for performance issues, right? So it's not a good idea. So what it does behind the scenes is a kind of a locking. It handles the locks differently. Imagine that you do a select and you read, let's say, 1000 rows, and in serializable mode it just locks all the rows. So the other transactions will wait for you to free these locks or remove these locks so they can read it. So it kind of mimic the behavior of a serialization. They don't happen one after the other, but they try to mimic that. Of course, if you use the MVCC, which is active on the PostgreSQL, you will have you will avoid all these lockings on the serializable, because it will create different versions, so you'll not have problems of the locks. So the other transactions, we don't have to wait after you read this transaction, this value, because they will have their own version, so it will be smooth. That's why they say that that Postgres it's really good on the serializable isolation level. Okay, that's one of the features. A second feature that I want to talk, it's window functions in Postgres. So imagine that you have a data, a lot of rows, and sometimes you need to compute parts of that. You want to split that data in blocks, and then you want to create things. Of course, you are thinking about, I can do it with a group by, but sometimes you want more than that. You want to rank them, you want to create small averages, you want to compare with the previous value. There are a lot of functions that you want to apply that you don't resolve with a grouping, and you have a lot of them. I put a few of them here. You have row number, rank. Row number, it's a great to generate numbers. Rank, which is a kind of a position like a rank in a contest. Dense rank, entile, aggregate functions like sum, average, count, the usual stuff. And then you have value functions like lead, lag, first value, last value. I like you to check on the internet what they mean. Again, in future videos, I will provide more deepening on this. So if you want to check once in a while on my channel, you will see these videos appears also. But let's see an example so you can understand. Imagine you want to rank your sales by their total sales. So imagine that you have a table and you want to, I will explain this in a moment what it does, but you want to calculate the rank, and I will show you a table in a moment, but you want to apply that by sale month. Imagine that you have January, February, March, and so on, and you want to say, okay, who sold most on January and in February and in March. It can be a real challenge thing if you use native SQL. Probably it will be very difficult. Probably you'll start to create a standard procedure to do that. But with this, like this kind of functions or window functions, you have this rank over, and you say the attribute that you want, and then you can even order and you give it a name. And this is the table that you are looking for. So let's see an example so you understand better. Imagine that this is two tables. You can see this is the original and this is the result. So imagine that you have this table, Alice, January. You can see here we have January and February, okay, and you have these values. And then you apply the query that I showed previously. So we went to sales rep, which is the representative, okay, the sales month, January and February. We want how much was the sales, and now we want a rank. We want to check, we want to create a rank for these representatives, and we expect something like this. And you can see here, if you look into January, you have two persons, Carol and Bob, which are the first, and then you have the Alice on the second. But since there are three persons, the rank is quite clever, because he assumes that, okay, these are two persons, they are at first, and you can see here the result, but this is on the second, but it's the third because there already exists two persons with the same value. So this is the third position. There is no second position. There are the second position, they are this Bob and Carol, they are the first and the second. at the same time. And the same applies for February. And you can see quite simple is to do this. Of course, you can apply this to sales or to other types of queries that sometimes we don't know how to resolve quite complex things, and you can use, for instance, the rank, but there are other functions. Please export in documentation. But you can see with a simple query, just select from without grouping bys and things like that, subqueries, complex joins or something like that, you can create a very useful result. Another thing that you have, it's called common table expressions. And I remember that this exists in other databases also, but it's supported by PostgreSQL. Again, I'm not saying that PostgreSQL is better or has other things that other databases don't. I'm just trying to prove to you that it's a solid alternative and quite reliable. So, but what are CTS, called common table expressions? Let's say it's a kind of a view, if you want, like as if you are creating a temporary table that only exists for a single query. It's like as if you have a temporary view of some data. Okay, a view, you can create a view in database and create and you register, and you can even materialize it if you want. CTAs, it's when you want to perform a query, you don't want to create a view, but you need kind of a window of data and you want to work with that. But at the same time, this window works as a kind of a table, which is quite nice. You can, it's not used to insert, but for complex queries like recursive queries, you can do it. Okay, one way to see it, how it works, it starts with the with, then you put the steps like this way. I will show you in a moment how it works. So first you provide the main query that you want, and then you provide what do you want to apply to this query. And since this has a name, you can, for instance, in this query, refer to this, let's say, temporary in-memory table here, and you can even join with it. And that's one of the tricks used to create recursive calls. And then you provide your final select. And if you want to see as a kind of a tree structure, so you have the big query, important one, then you apply as many steps as you want. Of course, there is a limit, but it's not one or two. It's more than that. And then you perform your real select. So let's see an example. Imagine that you have this table here. You have a category name, and you have a parent category. This is one of the previous solutions, and I remember to do this more than 10 years ago in SQL Server when they introduced the CTA, when you wanted to use recursive queries. So you have this parent and you want to create a relation between, you start with one and you start to get the childs and the childs of the childs and so on and so on. And you can do this with this CTA. So you say use with recursive, you can even use this word subcategories here as, and this is the name, it's not a table that exists, it will exist when you write it here. And then you say, I have a select category ID from categories, and I start with the laptops, that's what you see here. And then you union with another category, it's the second step. And you say, okay, now I go to the categories, and you can see that I'm joining the categories with the subcategories. So I can join this one with this one, and it will recursively goes until it stops, probably when it reaches null, when the join doesn't work anymore. So you can see then the output select P from products. This is the products join subcategories, which is this query here on this category. So I'm not doing the category because it's a table that exists, but I'm joining here on the subcategories, my products. And then I will see for each one of the products how many exist, what are the products inside specific categories. That's one of the approaches and one of the, I say, most used. I will say that probably it was the main use case that brought this feature about CTS to appear in many databases, the recursive need on the SQL. Another one that we have, it's the full text search, and it's quite interesting because the full text search in the PostgreSQL doesn't need an additional service like other databases. Of course, it needs an extension that to handle this TS vector here, but you can, after you install the extension, you can use it in a query in a regular way. For instance, if you, let's imagine, I think I have an example. Okay, it's all the example. It's here. So let's see an example. So imagine that we have a table with these 3 rows, and there are 2 approaches here. One is you create a table like this, and you want to, let's say, index the subject here. And for that to happen, you just apply this 2s vector like this, and when you are doing the insert, and with it will and on the this column you can create a trigger when you're doing the insert, and say, okay, every time there's a new row or update of the subject, please recalculate search vector. And it will internally, it will be something like this, a kind of a weighting mechanism. Here it will clean these nodes, hands, hors, and things like that. You understand that's connecting is the same as connect. It means that it will treat the same way. So it's kind of a clever way to index text. And by the way, this can be used even for LLMs and things like that to help on the AI when you want to do some queries. I have tried in the past and it works quite well. So when you perform the query, you have two ways. Or your table already contains this column, and in that case, you just select and say search vector, use this symbol here, and you use to TS query, and then you say, I want Wi-Fi and not slow or network. Okay, you can use booleans here, and you can say what expressions are you trying to find and not to find. It's a great way to do this kind of search, and then it will consider these weights here and will perform the best results here on the test query. So you will see what you are really asking. Okay, but in this case, it means when you use like this, it means that the column already exists. It was created by you and filled every time there was a new or updated subject. But if this column doesn't exist and you still need to perform this kind of query, you can, rather than use search vector, you can do like this. Like it's the same function that you use it to fill this column, but since the column doesn't exist anymore, you just do to TS vector. You put here the value, which is what you expect here on the subject. It's okay. The subject that's here. This is the language to consider on the subject to do, because of course in different languages the words are different, and the way and you understand. I don't have to explain that. Each language has its own structure, and then it's the same here on the right side. So in this case the column exists, in this case you don't. So if you have already tables and you want to test yourself, just create a table, perform this query and use this. If it's English, if it's not English, look for the language that are supported by this, and you just test it and you can play with it. I think it's quite nice, quite fast, and you don't need an additional server service for searching. Of course, you will not build a Google with this, but for simple data like search on websites and things like that, it can be quite useful and quite fast. Why not? Another one that it's probably one of the most popular and required is the JSON and JSONB for modern web. JSON, it's everywhere, and sometimes we don't want to create a lot of tables with attributes or recursive tables or tables with child tables with a lot of relations when we want to store a kind of a JSON structure underneath to query from it. And in this case, Postgres shines because it already supports JSON and JSONB by default. Okay, so with this example, it should be simple for you to understand how it works. Imagine that you have a table, update product, set attributes, and now you have here a JSON that you are putting there. So you have the color, blue, sizes, with a list here, material, leather, and so on. And now, of course, there is a specific notation for you to use, but now you can query this JSON. So you have select product name from products where, and I say, okay, go to the column attributes and find the color for the blue. So this one will be cut. And if you have others, of course, the JSON can be bigger than this one. You can filter, and behind the scenes, he understands with this operator that we are talking about JSON, so he can extract only the rows where this is true. And of course, it can be quite complex. I think I cannot be more simpler than this one. Of course, you can have sub hierarchies here, and you can use it here to go to the sub attribute, and find things. Behind the scenes, the Postgres doesn't need to always parse this. You can index it so it can be efficient. He understands the schema, and it can be efficient on the queries. I think it's a great feature, for configuration, things like that, it's a really good addition. Another thing that sometimes people don't expect to see on the database are arrays and ranges. Let's see what are these features. You know already, if you are a developer, what are arrays. You can put a list of items on a single column. So let's see how it works. Imagine that we have this create table, the primary key, a product name, and now I want a set of tags. And usually in the past, you just create a varchar and put a comma between words, and then we try to do a kind of like or something to extract to check if it exists. If you want something more advanced, sometimes you create an additional table, call tabs, and you do a select in to check if it exists. In these cases, we can just use one column, and Postgres will handle for us all these mechanisms to find these tags or whatever you put on the array. So in the insert, you can do something like this. You just use the word array and you put here the values that you want. And then when we are selecting, we can use the word any, and we'll say this waterproof exists in one of these tags. In our case, it will be exists here and here in these two rows. And that's it. It can't be simpler than this. Another thing that we have, it's ranges. Sometimes you want to test if a specific number or specific date, it's between specific values. And sometimes it's difficult because it depends on the type that we are target on the range. And the Postgres can facilitate our life with that, with this ranges mechanism. And you can see here, again, we have we create the data type, call it date range, and we say, okay, so there is a room and it will be between these two dates. And that's great, because he understands the concept of a scope of time or even other data types regarding ranges. And now what we do is that, okay, I want to check all the reservations that are inside this range. I don't care about how to compare the equals, the time, the nothing. I will just put this and here, and it will check for me, and this function will take into consideration my value and will check if it belongs to the range or not. I think it simplifies the life a lot. I remember all the nightmares that I have with this when I was a developer, because sometimes we are not using the date, you are using date time, and then you are trying to check if it's on that day, but since the record was created close to the final of the day, it seems that it will not appear on the results. They are quite difficult things to trace, and when we have these behavior bugs, it's very difficult to find. And this can be simply resolved with these ranges by Postgres. Another thing that you can do is define your own types. Imagine that you want to create a money type like this. So, and for money, we want an amount and a currency. So we create a type like this, money, we perform the amount, the value, and the currency that we want to apply. And now when you create products, you can say this product ID, the price, it's this one. So I can have a price in any currency and with the value. So when I insert, of course, I need to specify. I would say, okay, I have this kind of a tuple with the value and my string, which is these two attributes, and associate with the type money, because you can have other ones that they have the same structure, like numeric and char. So the overloading will not be a good way to find the right type. So you specify like this. And now you can use the dot to access the details of each one in your query like regular columns, which is great. And I think we can agree that we can simplify a lot of things with these types. Okay, that's the main features that I wanted to show you. Now I will move into extensions. I will not explain all of them, but I want to show 2 or 3 so you understand the why Postgres is strong on extensions, and why it's becoming so popular, and why people love extensions on the Postgres. So let me first show you some of popular extensions. Some of them I use them, others I didn't, but I know about them. So PostGIS geospatial queries and mapping, really useful in today's projects. I think GPS, it's everywhere for everything. Fuzzy text search and simulator meshing if you want something advanced. Key values, sometimes you want to store, you want an optimized way to key values. It's you can always say, okay, it's like having a table with the key and the value. Yeah, but this one can really work like a key value if you're looking for it. You go into details to understand the difference. And behind the scenes, probably you don't know, but there are a lot of products that behind the scenes, they use key values, even for caching mechanisms and things like that. And with HStore, it can be a really useful addition. So if you need to manage key values, check this extension before going directly to a simple database with a key and a value. Generate universal IDs. I use this a lot. Sometimes you want something that is unique along all for all the servers of in your architecture. That's one way for you to generate it. Then there are simple things like case sensitive, text type, table functions, B-trees, crypto. I use it to hashing and encryption. Sometimes we want to hash things inside the database. You have PJ crypto. I use it. Postgres, this is quite good if you want to integrate your Postgres with other databases. TimescaleDB, it's quite powerful because it turns your Postgres into a completely different database. It's like a layer over your Postgres, like a time series DB, like something like when you have metrics and the timestamp. It's really important. You want the history. You want to create nice charts about metrics or similar things. TimescaleDB, it's quite popular if you go into internet. When I first saw TimescaleDB, I thought that it was a real database, but it's not. It's an extension over the Postgres that turns the Postgres into a timescale database. I think behind the scenes there are no. It's not. I want to check if Prometheus is using TimescaleDB behind the scenes, but I think it's not. But there are some products that they use they need this timeline for things, and they use the TimescaleDB behind the scenes. If you do a search about TimescaleDB, you will see how many products use this Postgres/TimescaleDB extension. Okay. Then you have things to partition big tables, and you can even develop store procedures in JavaScript version 8 engine if you add this extension. There are other ones. Some of these ones are quite popular. I will say that this one, HStore, PostGIS, pgcrypto, timescale, really popular. This one, if you want to integrate database, I think there are 6 or 7 here that are really popular. Okay, let's see some of the extensions so you know how it works. I don't have all the logic here. I will explain in future videos. At least I will dedicate a few videos for each one of the extensions. Basically, you start with a query, something called create extension. Create extension is not to create extension, it's a way for you to import an extension to the database. And and after that, the database starts to use the functionality of that provided by that extension. But let's see that you already did the create extension for this PostGIS. And then you can do something like calculate the distance between one location and another location. We do just one query. It is as simple as this, and that's it. You don't need to develop crazy things in C++ or other language, then integrate inside your Postgres database. The extension already provides everything that you need. Another one, it's this one for adding the data wrappers. It's when you want to connect to other databases. Imagine you want to create Postgres with a different, like MySQL Server or other one. What it does is it will import not the data, but the scheme and the relations from the other server. Of course, there will be the need to provide username and password, and then it will handle locally, like they will handle the remote tables like if they were locally, meaning that you will see these tables like if they were on your server on your selects. Okay, so let's see an example. Again, I have okay. By the way, I have a way for you to see how you can import an extension. Let's say create extension Postgres, this one, to integrate with another database. Then you create a server. These are the things that you have to do. Foreign data, where it exists, what is the remote host, what is the remote database. Imagine that you are connecting to another Postgres. Okay, now it's necessary for you to assign a user because there are permissions always involved. You cannot access any database without any permissions. But now you import the schema. So you create it's not mandatory. You go to the public schema by default, but it's not a good idea because you can start to have a collision between the names of the tables, remote tables with your local tables. So you want to create a schema for the remote tables. Of course, don't give this name remote tables. Give it a name, maybe finance DB remote, something like that. Now import schema. Okay, as I said, and now you select, and you can see here that when you do this remote tables customer, you are accessing these customers that belong to the server that you connected before. And that is as simple as this one. Again, the other database, Oracle's, SQL Server and things, they support this, but again, so Postgres in a quite simple and elegant way. So another thing that you can do in databases, I usually try to avoid it, but sometimes it's something that is necessary, is to create storage procedures. And in Postgres, you can use different language. It's not, you can use SQL, the PostgreSQL. You can use even Python or even JavaScript, as I said previously in one of the extensions. So imagine that we want to create in SQL. It's quite simple. Create or replace function. Okay, you provide the parameters, then what is your return type? In this case, it will be a table because it's the result of a query. Then it returns a query, and then you provide here the select, and you say here language, the Postgres language, and then you select from, and since it returns a query or a table, you can use it, for instance, in a from, and you can create this kind of store procedures / functions for everything as you wish. You can even return ints and use in wheres or selects or whatever you want. Okay, it's like a method in a language. Let's say it like that. But you can also use Python. Okay, of course, you need the language here. It's different, but again, of course, it's an extension for Python. And then, but the rest, it's very similar. Create or replace function, the name. Here, the parameter, what you return, and then you will see a lot of this operator here. And then you can see here, this is just Python, which means that, of course, behind the scenes, there will be a kind of a compilation for this code when it will be executed, and it will not be the database executing this, but it will be the extension. But it's the same CPU, it's the same concept. So don't expect a reduced performance. Why? Because when you are using Python, it means you are not doing queries. You want to receive something, maybe the result of a query or for each one of rows, for instance, and you want to process something and return a value. So there is no, it's not that you are, you have the option between Python, for instance, and this one. That's not, and SQL, because SQL has a purpose when you want to handle rows and tables. Python is when you want some computation about some values. And for instance, here, just detect outliers and you provide an array. By the way, array, you already know that it's supported by Postgres. And you can have also the JavaScript version. It's the same, again, create extension. Now, of course, the extension is a different one. Now you have create or replace function, the name that you want to give to your function, the parameter. And again, in this separator, you can see here the JavaScript code. It's quite behind the scenes. Of course, the extension supports the version 8 engine for JavaScript, and you can use it as a storage procedure. People sometimes like the JavaScript. Maybe they have already some functions that developed on the business side and want to put on the database to resolve specific problems. I don't like it personally as an architect, but sometimes it's necessary. I remember that once I was developing a system where it was necessary to calculate the rating of calls, phone calls, and it was not straight because there will be different prices when it was on holidays, weekends, different zones. There are a lot of different parameters. So it was quite fast on the application because the calculation was being done in C#. At the time I was using C#, but in SQL it was really complex to implement. As I tried, but the SQL it's not optimized. And sometimes if it at the time there was no Postgres, it was several years ago. And if there was, of course, I would prefer to develop in Python or maybe JavaScript and put the engine to execute it. It will be faster, and I could have made my life easier during that development. So as we have this JSON, JavaScript language that you can use for a storage procedure. So let's compare now the Postgres with other databases. Again, it's not to make it better, it's just to make it, let's say, side by side. Okay, that database type, the MySQL, it's a pure relational if you compare it to MySQL. Postgres, it's object relation, as we saw, and with extensions you can do whatever you want. Postgres takes data correctness very seriously. Sometimes MySQL can be more relaxed depending on the engine, and I have issues in the past because of this if you target the wrong engine. But if you choose well, that it's not a big advantage for Postgres, it's just a different way. Concurrency, MVCC, means no waiting for read writer. MySQL probably use locking, which can sometimes slow things down. As I explained earlier, for instance, in isolation levels, if you have thousands of requests targeting the same set of data, MVCC can really do a big difference. Extensibility, yeah, it's amazing on Postgres, as we saw. Of course, MySQL, it's more limited. Advanced SQL, full support for all the latest SQL tricks. Every time there is a new thing, Postgres probably will support it. Usually MySQL follows the standard, at least the basic standard SQL that all the databases support. Okay, but as you saw, Postgres goes a step further. Use case, it's complex, crucial apps where data matters most, meaning that if you need a database that has to handle more than relational things and SQL things, Postgres is the way to go. If you want to simple SQL, I expect that probably you will find more use cases and implementation frameworks using MySQL rather than Postgres. Okay. About Oracle is quite advanced. It depends how much do you want to pay and how much resource do you have on your servers, and that's it. It's a really good database, but there is a price for it, and when I say price, in every sense, money and resources. So Postgres, it's free and open source. Oracle is super expensive and proprietary. Standard 6 to SQL standards, so it's portable. Oracle support use its own proprietary rules. They have data types like Postgres, they have a lot of things, but they work their own way. Extensibility, open source extensions are everywhere. Oracle, everything is proprietary. Even the Java start to be, at least for production. People didn't like it, Oracle. Data types, tons of modern types like JSONB, also has good support but can feel less flexible, but you have support, of course, for JSON. I will not say that Postgres has things that Oracle doesn't, but Postgres is missing something that Oracle has too much, which is money to spend. Okay? That's one of the things. And of course, support. If you are in a big company, probably you want to consider Oracle in some scenarios. If you have critical data and you want a really, really close support with high professionals and you don't have professionals on your company about Postgres, and that is always, it depends always on the context, of course. Okay, regarding use case, powerful, cost-effective alternative for almost anything. The Postgres, Oracle, older enterprise systems with big budgets. Again, money. If compared with Microsoft SQL Server, Postgres works everywhere. SQL Server, mostly Windows focused, but to be fair, it exists a version that runs in Linux. I executed and it works quite well. License, it's free. Of course, SQL Server, it's like Oracle, you have to pay. It's a company, they have to pay salaries, so don't expect nothing free from there. Extensibility, open extensions are a major plus. Here, features are built in proprietary in Microsoft, but to be fair, I've worked with SQL Server in the past a lot, and you can extend some things, you can develop using .NET, store procedures and things like that, but it's not as elegant, I will say, as the usage in Postgres, but it works. Okay, it works, to be fair. Postgres supports MVCC and concurrency. SQL Server, I know that it uses also MVCC. Sometimes it relies on locking. Even Oracle, I think I didn't put it before, but it also supports MVCC. But usually people say the MVCC, it's a key part of the design, meaning it's everywhere in Postgres. So it's smooth the way the isolation levels work. And of course, Postgres is super versatile for any tech stack, works best when you're already using Microsoft products. That's right, you can install SQL Server, and at the end of the day, it supports the standard protocols. You can access SQL Server like a regular database, even in Linux. I know that they have a version for that. But from my experience, when you start to integrate with products that are not Microsoft, and you need things like authentications and things like that, you start to miss the Microsoft environment. It's like the Apple somehow. It works, okay, but when with other tools, but yeah, there will be things that will not work as you expect they should. So a quick summary of why Postgres is the best. It's object relational, so you have more than just tables and SQL standard. It's built for flexibility, you have extensions, handles anything. I think JSONB, arrays and range, it's a great help. Even if you go to the search mechanism that we saw, I think and the window functions and the CTEs, I think it's great that you have that on the database. It plays by the rules, meaning that everything that you do in standard SQL, it should work on Postgres, and it has a big open source community and support, really. And as I said when I start this video, I work in banks, top 10 worldwide banks, and there are a lot of internal systems that were using Postgres. I won't say which banks, maybe you can guess if you go to my LinkedIn, something, but they use it. Okay, not only this database, but they use it in a lot of different systems. So this is what I wanted to present you about Postgres. I hope now you are convinced at least to consider to use this database on your systems. I hope I have enriched your knowledge about this database, and I hope to see you on my next videos about I would say any video on my channel. So subscribe, like it, share with your friends, and thank you for watching.